This is RD Sharma solution. We are taking class 12 chapter 19 and exercise is 19.30. We are talking about indefinite integrals. So we have done questions like this, but there is this x raised 4 which may seem a kind of scary, but if you see that if you just take x square equals to t, that is you take some alias or different name for x square. We are not differentiating x square or t. We are just saying that just imagine x square as t. So this equation will become like this: t divided by t square, because t is x square, x raised 4 is t square. So t square minus t minus 12, and this 12 can be written as negative 4 plus 3 because you can get a negative out of it. So we can write this as t square minus 4t plus 3t minus 12. You can take t common, it will be t minus 4. Now you can take 3 common, it will be t minus 4. So we have two factors out of t square minus t minus 12, which is t minus 4 and t plus 3. So this equation, after converting it to a partial fraction, this question has become quite easy now. You can just write a divided by t minus 4, and then we can have a b divided by t plus 3 in order to get a and b, and then integrate these two terms separately. If you wouldn't have taken t equals to x square, then the problem of solving this question would have enhanced. But we have simplified it now. Now take the LCM. A multiplied by t plus 3, then b multiplied by t minus 4. In denominator we have t minus 4 and t plus 3. So let's multiply. I'm multiplying it here. At plus 3a plus bt minus 4b. Now combine these two terms, a plus b, because these are similar terms, a plus bt, and 3a minus 4b. Denominator will contain the same thing, t minus 4 and t plus 3. And if you compare it with the left, which from where it has originated, you can cancel this t minus 4 and t plus 3 like this. Now let's equate a plus b into t equated with t, that is a plus b will become what? It will be 1. 3a minus 4b, it's 0. Because there is no counterpart in the left, there is no constant. So you can write 3a minus 4b equals to 0. So you can just take a equals to 4b by 3, or say b equals to 3a by 4 and put it in the first equation. Or you can multiply first equation by 4 or 3 and then subtract or add. So I have multiplied a plus b equals to 1 by 4 and just added it. It's up to you how you want to find out a and b. A will come as 4 by 7. If you put a as 4 by 7, b will give you 3 by 7. 7 minus 4 by 7 is 3 by 7. So the next step will be, we'll put a as 4 by 7. But before that, you have to put or replace now again this t by x square, because we have to integrate it now. So again 3 by 7 for b and integration of dx by x square plus 3. That's what we are doing right now. So what I just told you, I'm writing it in a fairer way. It will be 4 by 7 integration of dx divided by x square minus 4. You can write it as 2 square, because we'll use the formula. B came as 3 by 7 integration of dx divided by x square plus, we are writing not 3 but root 3 square, again using the formula. We are applying the formula just now. Now dx divided by x square minus a square. So what is the integration of dx divided by x square minus a square? We know the formula of this. It's 1 by 2a log x minus a by x plus a modulus. X in this case will be x only, and a in this case will be 2, and put it here. So this will be 1 by 2a. What is a? 2. So 1 by 4. 4 by 7 is already leading. So multiply this 4 by 7 into 1 by 4. You'll get 1 by 7 only, and use this formula which I just indicated you. Log x minus 2 divided by x plus 2 modulus. First part is done. Coming to the second part. Now we have to apply the formula of dx divided by x square plus a square. So integration of dx by x square plus a square will be what? 1 by a tan inverse x by a. You take a as root 3. So 1 by root 3 tan inverse x by root 3. Now 3 by 7 is also leading it. So just multiply this 3 by 7 into 1 by root 3. You can multiply numerator denominator by root 3 will give you 3. The numerator will get cancelled. So root 3 by 7 will come, and tan inverse x by root 3 and plus a constant of integration. This is your final integration. Now I told you how to do this, but the basic idea is to make you understand and write also, because until you write, how are you going to present the answer to the invigilator or the examiner? This is how you have to write. Okay, there are certain things which are not seen here, which I told you in a different way. You can follow that. So we have x square divided by 1 minus x raised 4, x to the power 4. So we'll take x square as t now. So this will be t divided by 1 minus t square, because t was taken as x square. So this will be t divided by, or a square minus b square formula I will use. A 1 square minus t square is what? 1 minus t into 1 plus t. So you can equate with a divided by 1 minus t plus b divided by 1 plus t, because we need to find out the partial fraction constants a and b. And you know this has been done by you quite a lot. So a will come as half, you already know that, and b will come as negative half. So I'll put a as half here. This will be half divided by 1 minus t. Now you don't have to write t. You have to replace this by x square now, because we are now starting to integrate again. For this b, negative half will come. So this negative I am bringing in between half in the numerator, 1 plus x square in the denominator. Now half you can bring in here. This half you can bring in here. Integration of a square minus x square formula you are going to use. A will be 1, x will be 2 in this case. X will be x only. So 1 by 2a log. See, this is not x square minus a square. This is a square minus x square. Those formula will change. A plus x will come in the numerator. So log a plus x by a minus x will come. So 1 by 2 into 1, that is 1 by 2 log 1 plus x by 1 minus x. Half is already in front, just multiply this, 1 by 4 will come. So this will be 1 by 4 log 1 plus x divided by 1 minus x. Coming to the second term here. So you are actually integrating dx divided by a square plus x square or x square plus a square. So 1 by x square plus a square is what? So 1 by a tan inverse x by a will come. So x square plus 1 square is there. So 1 by 1 tan inverse x by 1. So only tan inverse x will come out of this. Half is already there in front. So negative half tan inverse x plus a constant of integration. That is the whole integration you can do. Now what is step by step formulation of this question when you write? This is in front of you. There are certain things which are being done here differently. I have shown you differently. Since this question is just being done just before one question, that is 65th question or 66th question rather. So we will take x square equals to t first. This will give you t divided by t square plus t minus 2. We will take the factor. You already know how to make the factor. Then the a and b will come, and then put x square equals to t again, or t as x. I'll show you the reference. So this question is almost similar to the 66th question, and there are certain things. X square has to be taken t first, then you go above. 1 by x square plus a square, 1 by x square minus a square, and 1 by a square minus x square. This formula of integration will be heavily used. You need to remember them when you are solving this kind of question at the trailing end of this exercise. Now this question, 63rd question, I already did. I told you a different way or different approach to solve this. But those who want to do in a different way, I will show you a different way of doing it. It's somewhat cumbersome, you can say that. But it's up to you. You know, you go to different shops, your friend buys from one shop, you buy from another shop. That means it's choice. So I'm giving you a choice. You can go back to 63rd question and see how it was done. But if you want to do it the way I am telling you, this x square plus 1 and x square plus 4 will be represented in the form of x square plus 3 and x square minus 5. So what I am trying to suggest here is that x square can be placed as t. See, even if you place x square equals to t, the numerator denominator order are same, x raised 4. So you ought to divide them. So when you are dividing them, that is the main key of division, which we have learned in question number 63 also. So what we'll do here is we'll write x square plus 3 in the numerator with a negative 2. X square plus 3 minus 2 is what? It's x square plus 1 only. So essentially we are writing x square plus 1. Similarly, x square plus 3 we are writing. 4 we are writing. How we are going to write? X square minus 5 plus 9 is x square plus 4 only. But we have actually introduced x square plus 3 and x square minus 5 because of the denominator they have. Denominator is x square plus 3 and x square minus 5. That's why we have taken it. So x square plus, now I am multiplying each and everything. X square plus 3 multiplied by x square minus 5, then x square plus 3 multiplied by 9. So 9 into x square plus 3 you can write. Then multiply negative 2 by x square minus 5. So minus 2 into x square minus 5 will come. Then minus 2 into 9 will be negative 18. See, denominator remains the same. It will always be x square plus 3 and x square minus 5. So just assume that there is a denominator for all these terms, and we are going to separate these terms with this denominator. So I am just separating each term with the x square plus 3 and x square minus 5 in the denominator. So let's just take this. X square plus 3 and x square minus 5. X square plus 3 and x square minus 5. And what benefit it will give us, that most of the cancellation, the integration will become quite easy. That means The first term will get cancelled, only 1 will come. The second term, if you cancel x square plus 3, only 9 divided by x square minus 5 will come. If you cancel these two, minus 2 divided by x square plus 3 will come. And this will be a separate term. We are going to integrate it separately. So x square plus 3 and x square minus 5. So now we are integrating it. So the partial fraction has already been computed, not for the last term that we will do just now. So the first term was 1. The second term was 9 divided by x square minus 5. Then we have minus 2 divided by x square plus 3. And finally 18 divided by x square plus 3 and x square minus 5. Now this term, see, first, second, third term you can integrate it easily. The fourth term, we can have these two separate terms out of the fourth term, and a by x square plus 3, b by x square minus 5, and that will get combined with the second and third term. That is, I am just doing it separately, x square plus 3 and x square minus 5 in the denominator. I am taking x square as t. It will be 1 by t plus 3 and t minus 5. You can write it as a divided by t plus 3 plus b divided by t minus 5. I am not differentiating x square and t. I am just saying that I have taken an alias or different name from x square, which I am calling it as t, and a will come as negative 1 by 8, b will come as 1 by 8. You can do that. I know that you will be able to do that. I am just writing a and b after computation. So this negative 1 by 8 and 1 by 8 will come along with this x square plus 3 and x square minus 5. Now you need to multiply it with negative 18. Just multiply it with negative 18 because I am just talking about the last term. So this will be 9 by 4. This will be 9 by 4. In the denominator it will be x square plus 3 and minus here. So minus 9 by 4, x square minus 5. Now this whole has given us two terms. So 9 by x square minus 5 will get combined with 9 by 4 x square minus 5. Negative 2 by x square plus 3 will get combined with 9 by 4 x square plus 3. Alright, these two terms will get combined because the denominator has x square plus 3 common and there is only constant term left. In the middle one also x square minus 5 will be taken and constant term will remain. So there will be a combination of that. What will be 9 by 4 minus 2? In order to take these two, first and fourth term, it will be 9 minus 8 by 4. Let me do it. So 9 by 4 minus 2 will be equal to 9 minus 8 by 4. So this x square plus 3 in the denominator will have 1 by 4 along with this. Okay, understood? Now coming to this second term, x square minus 5 and x square minus 5. So this will be 9 minus 9 by 4. So this will be 9 4 is 36. 36 minus 9 by 4. This will give you 27 by 4. So x square minus 5 will have 27 by 4. This x square plus 3 will have 1 by 4. So only one term will come for x square minus 5. One term will come for x square plus 3 as the denominator. So let me write the final thing. I hope you understood everything. So 1 plus 27 by 4, which I just computed, and 1 divided by x square minus 5 in the denominator, plus 1 by 4 and 1 by x square plus 3. And we have to differentiate with respect to dx here. Integration of 1 will be x. This will be 27 by 4. Integration of dx divided by x square minus 5. You can write it as root 5 whole square. 27 by 4. X square minus a square is what? X minus a into x plus a. But we will use the formula here. 1 by 2a log x minus a by x plus a. So integration of dx by x square minus a square is always 1 by 2a log x minus a x plus a. So I am writing it right now. 27 by 4 2s are 8. 8 root 5 log. You can write it as ln because it is log base e only. X minus root 5 divided by x plus root 5. For the final term, we'll use 1 by x square plus a square. So integration of 1 by x square plus a square we are going to use. For that root 3 square will come. So 1 by a tan inverse x by a. What is a? A is root 3. 1 by root 3 tan inverse x by root 3. 4 is already there, so 1 by 4 root 3. So you can write this term 1 by 4 root 3 and then tan inverse x by root 3 plus a constant of integration. This whole is the integration, final integration. So this is a different way of doing it. This is different from the question number 63, which already has been explained to you. Whichever way you want to do, it's up to you. Both ways are acceptable. So this is all about this exercise. Thank you so much. Have a good one. Take care of yourself.